Okay, now we're going to talk about internal validity. So internal validity is about causal claims. So it's asking, are your causal claims valid? So remember, validity is always about a claim or inference. So in this case, it's asking, is the claim, we found that X caused changes in Y. Is that a valid claim? So do we have a good reason to believe that the relationship between X and Y is a causal relationship where X causes Y? So to assess internal validity, there's a few steps. The first question to ask is, are the authors even making a causal claim? If they're not making a causal claim, then internal validity isn't relevant. It's not that the study lacks internal validity, it's just not a relevant question to ask. So it can be hard to tell if authors are making a causal claim or not. And some argue that almost all research in psychology and in many social sciences really is trying to get at causality, that most research questions are interesting mainly because we want to understand the cause and effect, what causes these outcomes, like divorce or financial success or things like that. However, there are cases where researchers are very careful to restrict themselves purely to a non-causal claim, or what's sometimes called an association claim, just claiming that two variables are associated with each other, but not making any claims about what's the causal reason or story behind that association. So it takes quite some training to pick up on what are the phrases that researchers use when they're trying to imply or explicitly state that there's a causal relationship. Some are obvious, like X causes Y. Some are less obvious. And many of these are phrases that we use in our everyday lives, and often they're used in a similar way in research, but not always. Sometimes there's jargon, and so a phrase just takes on a certain meaning in research that it doesn't have in everyday life. So here's a figure from Beth Morling's textbook with some examples of phrases that often are used to make association claims. So for example, X is linked to Y, X may predict Y, and then phrases that are often used to make causal claims. So not just X causes Y, but X exacerbates Y, or X hurts Y or promotes Y. Those are all causal verbs. Some of these can be somewhat ambiguous and can be used in either category depending on all the language around it. So a lot of it is happening in the kind of implicit, subtle cues in the language that researchers use. But a couple of interesting things to note is that in the context of scientific research, predicts is almost never a causal phrase. So if you see someone claim that something predicts something else, they're probably not making a causal claim, although it can sound that way. And is a risk factor for is also not a causal claim, which to my ears sounds jarring. I interpret as a risk factor for as if you do X, you're going to be at higher risk for Y. That sounds causal to me. So this distinction is very, very blurry, and that's not a coincidence. Researchers are often kind of in this gray area between association research or correlational research and research that is attempting to get at causality. And the two aren't completely separate. Finding out what's associated with what can help us make better guesses about what causes what. And there are some cases where we had to draw on correlational research that couldn't manipulate things to make causal inferences. So correlations and associations are very relevant for causal claims, but association and correlation are not the same thing as causal claims. This kind of ambiguity was captured well by the author of the XKCD comic when he wrote, "Correlation doesn't imply causation, but it does waggle its eyebrows suggestively and gesture furtively while mouthing, 'Look over there.'" So now I'm going to pick on an example of a paper that was written by my friends. So the authors are my friends. I think it's a very good paper. I'm going to pick on it just to make a point, and this is not at all to single them out. Many, many authors use language like this. I just want to point out how easy it is to kind of slip back and forth between association language and causal language. So the title of the paper is "Loved and Lost or Never Loved at All, Lifelong Marital Histories and Their Links with Subjective Well-Being." So already from the title, you can tell what variables they're talking about. They're talking about whether people were married throughout their lives or not, and how that's associated with subjective well-being or your life satisfaction. And links with is an association phrase. So here they're careful to just say, is there a link between marital history, whether you were married and stayed married, and your life satisfaction or subjective well-being? And indeed, in their abstract, they also use association language. They say, actually, I'm not sure if this is from the abstract or the main text. I think this is from the main text. They say, when examining life satisfaction, we found that the consistently married individuals, people who were married and then never got divorced, had higher life satisfaction compared to consistently single, people who never got married, and varied history, people who were sometimes married but then were not married again. And so this is, again, they're careful not to make a causal claim. They're just saying this group was higher in life satisfaction than these other groups. However, when you get to the abstract, you see they wrote, in order to determine if different marital histories have unique impacts on well-being in later life, blah, 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 blah. This phrase, unique impacts on, is a causal phrase. So if you were reading this, you might think, oh, they're testing the hypothesis that your marital history impacts your well-being. That's a causal phrase. So this first step of asking, are the researchers even making a causal claim, can be a lot trickier than it sounds. And I would err on the side of thinking that probably the researchers are interested in causality most of the time. There are exceptions. And then the question is, how careful are they in their language of, do they make it explicit that while we're interested in causality, these data only allow us to look at the association, or do they make causal claims from their data and say, we found that X impacts Y, for example. Assuming there is a causal claim, either an explicit one or one that's kind of implied or worked in between the lines, then you can ask, okay, does it have internal validity? Is the causal claim valid? So to answer this question, the first question to ask is, was it an experiment or not? Because how we answer this question depends on whether we're talking about an experiment or a non-experimental study. So if it was an experiment, we can conclude that systematic differences in the outcome variable across the different conditions are caused by changes in the predictor variable, are caused by which condition you were in, or the manipulation, but only if a certain number of conditions were satisfied. So first of all, we have to make sure that the predictor variable was indeed manipulated, so it's an independent variable, that the manipulation controlled the levels of the predictor variable. So which manipulation condition you were in determines what your level of the predictor variable you got, or what level of independent variable you got. And the manipulation didn't change anything else. So everything else was held constant. We also need to make sure there was an appropriate control condition that was matched on everything that the experimental condition got, except for the manipulated variable. We want to make sure that participants were randomly assigned to conditions of the manipulation, to different levels of the predictor or independent variable. Also, that there wasn't a selective attrition. If people dropped out after random assignment, that would be a problem for the validity of the causal inference. And we want to make sure that we can rule out all possible confounds. So demand characteristics, selective attrition, as I just mentioned, and so on. So other things that might have caused differences between the groups, like different people dropping out, or participants figuring out what the experiment is about, and so on. We want to make sure we can rule those out. So in the context of an experimental study, it's okay to make a causal claim as long as many of these assumptions and many others are met. So this is just a preliminary list of some of the more common threats to internal validity in the case of experiments. What about non-experimental studies? So if it's not an experiment, it's often hard to justify causal claims, but not impossible. So even though you've heard the mantra, correlation does not equal causation, we can still sometimes make causal inferences from correlational or observational data, but we have to be really, really careful. So we have to consider all possible alternative explanations. And when we're not in the context of an experiment, when we didn't manipulate the predictor variable, there's all of a sudden many, many more alternative possible explanations. So what are some common alternative explanations? One is reverse causality. So if you observe an association between X and Y, it's possible that X caused Y, but one alternative explanation is that Y caused X. So for example, in a paper that I have come across, the researchers examined the relationship between how frequently a couple has sex, these were among couples, people in relationships, and their life satisfaction or happiness. And the researchers found that the more frequently a couple had sex, the more happy the people in the relationship were. And this was true up to once a week, and after that it flattens out. So it might be tempting to make a causal claim here that having sex more frequently, up to once a week, makes people happier. But we have to seriously consider the possibility that it's the other way around, that being happy might have a causal influence on having sex more frequently. So that's an alternative explanation here that we can't rule out with these data. Another possible alternative explanation is that there's a third variable, that something else is causing changes in both the predictor and the outcome variable. So in my example, maybe how much free time people have could be a third variable that causes both. The more free time you have, that might cause you to have sex more, and it might also cause you to be happier because you have more free time. So that's a really important thing to consider, and there's a whole universe of possible third variables in many cases. Another thing to keep in mind is this phenomenon called regression to the mean, which is that if you select participants based on the fact that they're extreme on something, for example, they're depressed or they are extremely happy, and then you observe a change over the course of your study, a very likely explanation is just that things tend to go back to normal over time. So if you select people because at that moment they were extreme on something, then probably over time they will go back to more average levels. In the textbook that I mentioned before, the Shadish, Cook, and Campbell textbook, they write that many business consultants earn their living by capitalizing on regression to the mean. They mean that those people come in when something's really bad. They say, we'll save your business. You had a really bad quarter the last few months. We're going to save it. And really, they're just capitalizing on the fact that things tend to go back to average over time. So waiting would have worked just as well as hiring an expensive business consultant. So if you're in the context of a non-experimental study, an observational study or correlational study, the best way to make causal claims is to lay out all the possible explanations or paths for explaining the relationship between X and Y, and then discuss the assumptions you'd need to make to rule out all the other causal explanations besides the one you're claiming. So in that paper I picked on earlier about marital histories and subjective well-being, the authors actually did do this in the paper. In the discussion section, they said that while they found that the consistently married individuals had higher life satisfaction, actually in the next paragraph they say, there are a variety of explanations for these results. So marriage may indeed lead to higher satisfaction, X may cause Y. And then they say, or these groups may differ from each other before these transitions even begin. So that's an alternative explanation. That's a third variable explanation. That maybe there's something different between the people who end up getting married and staying married and the people who end up either never getting married or splitting up beforehand. Maybe the differences in how poor or wealthy they are, or in the resources they have, or other kinds of differences. Another one that they don't mention here, but I think is plausible, is reverse causality. That maybe being happy could cause people to enter into serious committed relationships and stay in them. And maybe being unhappy might be an obstacle to that, or might lead people to different paths. Okay, so to summarize, in assessing internal validity, you first want to ask, are the researchers making a causal claim? Very often they are. Sometimes it can be hard to tell. It's not front and center, but often there is one somewhere in the language they're using. So if there is, then you want to ask, is the causal claim valid? This is not black and white like all aspects of validity. It's on a continuum. And it depends a lot on how plausible you find alternative explanations. So in the case of an experiment, could there have been confounds or demand characteristics or selective attrition? In the case of a non-experimental study, are there third variables that are likely or plausible, or could reverse causality be at play? Experiments typically provide more justification for causal claims than do non-experimental studies, but you can sometimes make careful causal inferences from non-experimental data.